Dear student, today we will discuss about the next semiconductor device, that is the CMOS device. So there are some contents about the CMOS device and what is the characteristics of CMOS technology, characteristics of bipolar technology, and what is the combined advantage of these technologies, and what is the fabrication and what is the integrated circuits that is used for in CMOS device, and what is the advantage and disadvantage and application also. So here the history of semiconductor device started in 1930 when Lee had and Neil first for the MOSFET. Bipolar technology was started in 1980 and CMOS technology was also started in mid 1980. So later in 1990, there was a crossover between bipolar and CMOS technology. And by CMOS technology, both the MOS and bipolar device are fabricated on the same. The objective of the BiCMOS is the combined bipolar and CMOS. So this is the BiCMOS, which is the combination of bipolar and CMOS. So as it exploit the advantage of both the technology, today BiCMOS has become one of the dominant technology used for high speed. So BiCMOS is a very high speed device, semiconductor device, and low power and highly functional VLSI circuits. So generally BiCMOS circuit used in VLSI technology. The process step required for both CMOS and bipolar are similar, so that BiCMOS process has been enhanced and integrated into the CMOS process without any additional steps. The primary approach to realize high performance BiCMOS device is the addition of bipolar process step to a baseline CMOS process. The BiCMOS gate would be used an effective way of speeding up the VLSI circuits. The application of BiCMOS are vast. An advantage of bipolar and CMOS circuits can be written in the BiCMOS chips. BiCMOS technology enables high performance integrated circuit IC, but increase process complexity in BiCMOS technology. BiCMOS technology is a combination of bipolar and CMOS technology also. And CMOS technology offer less power dissipation. So there is very loss of power dissipation in CMOS technology. And there is very small noise margins also and higher packing density in the CMOS technology. So these are the some facts about the CMOS technology. And bipolar technology, on the other hand, ensure high switching. So BJT technology is the high switching device and input, output speed and good noise performance. Oh, and there is good noise performance in the bipolar technology. Now we are in third generation of BiCMOS technology. So BiCMOS technology accomplish both improve speed over CMOS and lower power dissipation than bipolar technology. The main drawback of BiCMOS technology is the higher cost due to the added process complexity. So this is the main drawback of the BiCMOS technology due to the higher cost, because there is the process is very complex. So this greater process complexity in BiCMOS result in cost increase compared to conventional CMOS technology. So there is the characteristic of CMOS technology here. So in characteristics of CMOS technology, there is lower static power dissipation and higher noise margins, higher packing density, and high yield with large integrated complex functions, high input impedance, low drive current, scalable threshold voltage, high delay load sensitivity, low output drive current, issue when driving large capacity loads, low transconductance, where transconductance GM and bidirectional capability, drain and source are interchangeable in this characteristics of the CMOS technology, and also a near ideal switching device and have the low gain. So there are some these characteristics of the CMOS technology. Next one is the characteristics of the bipolar technology. So bipolar technology have the higher switching speed and higher current drive per unit area, higher gain also, generally better noise performance and better high frequency characteristics, improved input output speed, particular significant with the growing importance of package limitation and high speed systems, and also high power dissipation in bipolar technology, lower input impedance, high drive current, low packing density, low delay sensitivity to load, high transconductance GM. It is essentially, so these are the some characteristics of the bipolar technology. Now, next is the combined advantage in BiCMOS technology. It follows that BiCMOS technology goes some way toward combining the virtue of both CMOS and bipolar technology. Improve speed over purely CMOS technology and lower power dissipation than purely bipolar technology, lower power consumption than bipolar. So flexible input output for high performance, improve current drive over CMOS, and improve packing density over bipolar, high input impedance, low output impedance, and high gain and low. So that is the BiCMOS application. So here in this figure, arrangement of BiCMOS NPN transistor or with 2 micrometer CMOS. So this is the fabrication of the BiCMOS device, in which there N collector contacts and also N emitter and contacts area, and P substrate here in this figure, and there are also N bells and BCCD very N plus subcollectors here, and also P plus base and base contact area here. And this is the plan view of the BiCMOS device. And next, second figure show the cross-section view of the BiCMOS device. So here collector, emitter, base is the 3 terminal of this device, and also a oxide layer in this diagram, and also N well and P base region here, and very N plus subcollector BCCD and P plus connection to the base. So for clarity in this diagram, layers have not been drawn transparent, but BCCD underline the entire area and the P plus base underline as within in boundary. So this is the BiCMOS fabrication. This is the BiCMOS integrated IC. And what is the advantage? So there are some advantage here. Improve speed over CMOS. Second is the improved current derived over CMOS. Next one, improve packing density over bipolar, and lower power consumption than bipolar technology in this technology, and high input impedance and low output impedance also, and high gain and low noise in this technology. And there are some disadvantages also in BiCMOS technology. In BiCMOS technology, increased manufacturing process complexity, higher cost, and speed degradation due to scaling, and longer fabrication cycle time. So these are the some disadvantages of the BiCMOS technology. And what is the process in BiCMOS technology? So first of all, there is a bipolar process, plus next is the well process, and next one is the gate oxide and poly process, and next is the CMOS process. So this is the serial wise process of the BiCMOS process technology. And what is the application of BiCMOS? So there are many applications. Full custom IC, ALU barrel shifters, SRAM and DRAM, microprocessor and also controller, semi-custom IC, register, flip-flop, standard cells, and ADARs, mixer, analog to digital converter and digital to analog converter, gate array, and flash D2A converter. So these are the some applications of BiCMOS device. there is the, in this figure, comparison between basic CMOS and bi-CMOS. So here is the some graph also given here. For first is the delay comparison, second is the load capacitance, and third one is the delay versus DC voltage supply. So there is the speed comparison between basic CMOS and bi-CMOS here. These are the also bi-CMOS products. Next is the RC coupled amplifier. So we have already discussed different type of amplifiers. For examples, BJT, FET, MOSFET, etc. Now we will discuss about the RC coupled amplifier in details here. So first of all, what is the amplifier? Amplification is a process of increasing the signal strength by increasing the amplitude of a given signal without changing in characteristic. So that is the amplification process, in which we increase the strength of the signal by increasing the amplitude of the given signal without changing any characteristics. So the input signal may be current signal, maybe voltage signal, or a power signal, and amplifier will amplify the signal without changing its characteristics. Okay. So application of amplifier are wide range. They are mainly used in communication, controller, audio and video instrument, etc. So that is the amplification concept of the amplifier. Next one is an amplifier which is completely based on transistor. It's basically known as transistor amplifier. The input signal may be current signal, voltage signal, or maybe power signal. An amplifier will amplify the signal without changing its characteristics, and the output will be modified version of the input signals. So application of amplifier are of wide range. They are mainly used in audio and video instrument, communication, controller, and so on. So first, now we will discuss about the single stage common emitter amplifier, because in coupled amplifiers there are many stages here in RC coupled amplifier. What we will discuss about the single stage common emitter amplifier. A single stage common emitter RC coupled amplifier is a simple and elementary amplified circuits. The main purpose of this circuit is pre-amplification, that is the make weak signal to the stronger enough for further amplification. So main function of single stage amplifier is the amplification, so that it make weak signal to be stronger enough for the further amplification. If we design properly, this RC coupled amplifier can provide excellent signal characteristics. This is the circuit diagram of the single stage common emitter amplifier. So in this circuit diagram, the emitter terminal is common between input and output side. So, and there is a only single stage used. So this name is the single stage common emitter amplifier. In this circuit diagram, we applied the input to the base by the uh, capacitor Cn, and we measure the output from this circuit at the collector terminal. So that is the output of this single stage common emitter amplifier. There are two resistance also, R1 and R2. So these are the biasing resistance, and RC is the collector resistance, and RE is the resistance across the emitter terminal, and also C is the bypass capacitor across the emitter resistance, and that capacitor used for bypass the signal in this circuit diagram. The capacitor C in at the input act as a filter, which is used to block the DC voltage, because this is the property of filter capacitor, which block the DC voltage and allow only AC voltage of to the transistor. If any external DC voltage reaches the base of the transistor, so it will alter the biasing condition and affects the performance of the amplifier. So here capacitor C in input capacitor as a filter, and which is used for the block of the DC voltage. And next, R1 and R2 resistors are used for providing proper biasing to the bipolar transistors. And R1 and R2 resistance form a biasing network which provide necessary base voltage to drive the transistor in active region. So in active region, the transistor we have as a amplifier, and the region between cutoff and saturation region is known as active region. So there are total three regions. One is cutoff region, second is saturation region, and between two regions there is a third region, that is the active region. So active region where the bipolar transistor operation is completely switch off is known as cutoff region, and the region where the transistor is completely switched on is known as saturation region. So in saturation region, the transistor is completely switched on, but in cutoff region, transistor operation is completely switched off. And resistance RE are used to drop voltage of BCC and also RC resistance. Resistor RC are a collector resistor and RE is emitter resistor. So then both are selected in such a way that both should drop BCC voltage by 50% in the above circuit. The emitter capacitor CE and emitter resistor RE make a negative feedback for making the circuit operation more stable. So in this circuit diagram, RE and RCE capacitors and resistors make a negative feedback in this circuit operation. In negative feedback operation, circuit is behave as a more stable. So next one is the two-stage common emitter amplifier. We use here the two-stage, stage first and stage second, and both stages are coupling by a capacitor C out to each other. So here generally use two transistor. Transistor first one is the first stage Q1, and transistor Q2 is the second transistor in second stage. And also there is the two biasing resistance R1 and R2 in first stage, and also there is a emitter resistance and bypass capacitor C is also here, and this stage is coupled by the C output capacitor to the next second stage, and there is also in second stage a two biasing resistance R3 and R4, and also there is bypass capacitor and emitter resistance across the emitter also, and we can measure the output across the collector current of the stage second transistor. So that is the circuit diagram of the two-stage common emitter amplifier. In this also the emitter is common between input and output side of this circuit diagram. And what is the circuit explanation? When input AC signal is applied to the base of the transistor of the first stage of this circuit diagram of RC coupled amplifier, from the function generator, it is then amplified across the output of the first stage. This amplified voltage is applied to the base of the next stage of the second stage amplifier through the coupling capacitor C out, where it is further amplified and reappears across the output of the second stage amplifier. So thus the successive stage amplify the signal and the overall gain is raised to the desired level. Much higher gain can be obtained by connecting a number of amplifier stages in succession. Resistance, capacitance, RC coupling or RC coupling or resistance, capacitance coupling in amplifier are most widely used to connect the output of the first stage to the input base of the second stage and so on. This type of coupling is most popular because it is cheap and provide a constant amplification over a wide range of frequency. So this is the circuit explanation of the two-stage RC coupled amplifier. Next one is the transistor as a amplifier, or when transistor behave as a amplifier. While knowing about different circuit for RC coupled amplifiers, it is important to know about transistor basics as amplifiers. The three configuration of bipolar junction transistor that are commonly used. First one is the common base configuration. Second one is the common emitter CE configuration, and third one is the common collector CC configuration. So operation amplifiers can also be used for amplification purpose. Common emitter configuration is commonly used in the audio amplifier application because common emitter has a gain that is positive and also greater than unity. So in this configuration, emitter is connected to ground and has high input impedance. Output impedance will be medium. Most of these type of transistor amplifier applications are commonly used in RF communication or radio frequency communication and optical fiber OFC communication system. Next, common base configuration has a gain less than unity. In common base configuration, the transistor have the gain less than unity. In this configuration, collector is connected to ground. Collector connected to ground. We have low output impedance and high input impedance in common base configuration. So in common base configuration, we have the low output impedance and high input impedance. In CB configuration, next one is the common collector configuration, is also known as emitter follower because common collector is also known as emitter follower because the input applied to the common emitter appears across the connected to ground. It has low output impedance and high input impedance. It has a gain almost equal to the unity in the common collector or emitter follower. Because emitter follower or voltage follower, the gain almost equal to the unity. Now, basic parameters of a transistor amplifier. So what is the parameters of a transistor amplifier or BJT amplifier? A good amplifier must have all the following specifications. So there are some specifications for the good amplifier. First one, it should have high input impedance. Second one is it should have high linearity. It should have high stability, and it should have high gain and bandwidth also. And it must have high frequency. So there are some specifications for the good amplifiers. Next one is the bandwidth. So what is the bandwidth? The range of frequency that an amplifier circuit can amplify properly is known as the bandwidth of that particular amplifier. The curve below represents the frequency response of the single stage RC coupled amplifier. So the curve which represents the variation of gain of an amplifier with frequency is called frequency response curve. So curve which represent the variation of gain of amplifier with reference, with frequency is called frequency response curve. The bandwidth is measured between the lower half power and upper half power points. So P1 point is lower power half power and P2 is the upper half power respectively. So Pi is lower half point and P2 is upper half power respectively. A good audio amplifier must have bandwidth from 0 to 30 kilohertz because that is the frequency range which is audio. So next parameter is the gain of the amplifier. So what is the gain? Gain of an amplifier is defined as the ratio of output power to input power, and gain can be expressed either in decibel or in numbers. Gain represents how much an amplifier is able to amplify a signal given to it. So this equation represents gain in number G equal to P out upon P input, where P out is the output power of an amplifier and P input is the PIN is the input power of amplifier. The equation below represents gain in decibel. Gain in decibel equal to 10 log P out upon P input. So gain can also be expressed in voltage and current. Gain in voltage is ratio of output voltage to input voltage, and gain in current is the ratio of output current to input current. So this is the voltage gain and current gain here. Equation for gain in voltage and current is so low. So gain in voltage equal to output voltage upon input voltage. Gain in current, output current upon input current. So these are the two gains of amplifier, voltage gain and current gain also. Next parameter is high input impedance of the amplifier. So input impedance is the impedance which is offered by an amplifier circuit when it is connected to voltage source. The transistor amplifier must have high input impedance in order to prevent it from loading the input voltage source. So that is the reason for having high impedance in the amplifiers. And what is the noise in amplifier? So noise refers to unwanted fluctuation or unwanted signal or frequencies present in a signal. It may due to interaction between two or more signals present in a systems, components, failures, design flaw, and external interference, or many be virtue of certain amplifier circuit. Next one is the linearity. So what is the linearity in amplifier. An amplifier is said to be linear if there is any linear relationship between the input power and the output power. Linearity represents the flatness of the gain. Practically is not possible to get 100% linearity, as the amplifier use active region like DJT, JFET and MOSFET also, which tend to lose gain a high frequency due to internal parasitic characteristics. In addition, this the input DC decoupling capacitor act set as a lower cutoff frequency. So what is the efficiency? The efficiency of amplifier represents how an amplifier can utilize the power supply sufficiently, efficiently, and also measure how much power from the power supply is gainful converted to output. So efficiency is useful expressed percentage, and the equation for efficiency is given by P out upon PS into 100, where P out is the output power and PS is the power draw from the power supply. So a class A transistor amplifier has 25% efficiency and provides excellent signal reproduction, but the efficiency is very low. Class C amplifier has efficiency up to 90%, but the signal reproduction is bad. Class AB stand in between Class A and Class C amplifier. So it is commonly used in audio amplifier application. This amplifier has efficiency up to 55%. That is the Class AB amplifier. And what is the slew rate in amplifier? Slew rate of an amplifier is the maximum rate of change of output per unit time. So slew rate is the maximum rate of change in output per unit times. It represents how rapidly the output of an amplifier can be changed in response to change in the output. So this is the slew rate of an amplifier. And next one is the stability. So stability is the capacity of an amplifier to resist oscillations. Usually stability problem occur during high frequency operation close to 20 kilohertz in case of audio amplifiers. So 20 kilohertz is the range of frequency of audio amplifiers. The oscillation may be high or low amplitude, but the frequency of oscillator, crystal oscillator, there are different, we have different type oscillators and generate the different frequency range, low, high, medium, etc. So amplification is a process of increasing the signal strength by increasing the amplitude of a given signal without changing its characteristics. And RC coupled amplifier is a part of multi-stage amplifier, wherein different stage of multi-stage amplifier are connected using a combination of resistor and a capacitor. An amplifier circuit is one of the basic circuit in electronics. So there is a book, Electronics Device and Circuit by the Millman and Alcaz for reference book for this topics, covering for this topic. There are some multi-choice questions. They are very important. And to clear the concept of this topic, so these questions are very important. These are also MCQ. Thank you very much.